Hello. So right now, I'm going to talk about the graph of the sine function. So what I'm going to try to do right now is I'm going to try to show you in as explicit a manner as possible exactly how the sine graph looks and how you want to and how to think about it. I want to convince you of more or less its shape. And then after that, I'm going to summarize with a few key points that I want you to know about. And by points in this case, I mean literally points on the graph that we're going to be using later on to graph some examples, some more complicated examples. And also, I will make some discussion of some of the properties of the sine graph that we're going to also formalize later. Okay? Okay, so without further ado, let's get started. So let me first start, for reasons that will become clear later, drawing a unit circle here, okay? Like this. And let's say this is the x-axis, okay? This is the y-axis, okay? And so I'm going to draw in my angles. Give me a moment. So here we have the unit circle, and I've labeled the angles here. I wanted to pause the video briefly so you didn't have to see me go through all that. And then what I want to do is I want to attach an x-axis over here, okay? And this will make sense in a few moments once we get started with this, okay? And I'm even at this point going to have to delete this for reasons that we're going to see right now. Oh wait, do I need to? No, we'll do without that. We'll just start here. This will be my y-axis, okay? And this will be my x-axis, okay? So the key thing is this. As we've seen, we defined the sine to be the y-coordinate of the point on the unit circle where the terminal side of an angle landed. So for example, and we're talking about an angle in standard position. So for example, pi over 6 here, right, is the intersection, or where I've labeled pi over 6. That corresponds to this side, and we're assuming that this line here is the initial side. This is the final side. And so we can see that that angle is pi over 6. And whatever y-coordinate that is, that would be the sine at that point. And we know if you have a unit circle nearby, you'll know that the sine there, the point, is going to be square root of 3 over 2 for the cosine and 1/2 for the y-coordinate or the sine value. Okay? And of course you can see that at the angle 0, right, the y value is 0. It'll be 1/2, then square root of 2 over 2, square root of 3 over 2, and 1. And likewise, as we go around, right, the y value here will be square root of 3 over 2, square root of 2 over 2, 1/2, 0 again. And then it's going to repeat this way, but it's going to be negative. And so what I want you to imagine now for a moment is this. So now the way I'm going to graph the sine function is I'm going to label, let me make some notations here. So what you'll see here is that I have put in these vertical lines. These are my grid lines, okay? Like if you have graph paper, I put these in so I can kind of have a sheet of graph paper here. And now, strictly speaking, they shouldn't all be like, what do I want to say? They're not as evenly spaced as they look here, but this is just to aid us in our drawing, and so you can see what's happening here. Now, so what I'm going to do is I'm going to show you how, so what is the sine graph going to be like? So what I'm going to do is I'm basically going to unravel the unit circle, right? And I'm going to paste it along here. And at each angle, right, at each, corresponding to each angle in the unit circle, right, which I have labeled here along the x-axis, I'm going to put a point designating the height of the unit circle, up or down, as the case may be. Okay, but now it's going to, now enough with words. So the first thing is this. At angle 0, what's happening? What is the y coordinate? At angle 0, the y value of the point on the unit circle is just 0, right? So I put my point there. At pi over 6, look here. We already agreed that the y value is 1/2, but here we can just look at it visually, and it's right there, you see? What I want you to kind of see here is how, like, I'm taking this height and I'm just kind of transferring it over here, like this. What about at pi over 4, which is our next bar? Well, it's taller, right? You see, I can just drag it over here. I can just imagine that I can take this stick, right? Let me draw it in here. Let's imagine I take this stick, right? And let's use this gloved hand as a measuring tool. So let's say it's this long. So I just take that over here. I put it against here. And you see I put my pointer. Oops, I lost the measuring, but you can see like about right there. Okay. Then you can see the next one will be a little bit higher, right? And then finally at pi over 2, it'll be higher still at about 1. Okay, so that's 1. So actually this should actually be a little bit higher. It should be like right here at 1/2. Okay. Of course, you know that my circle was drawn by hand because you guys saw me draw it. And of course, you know, even though it looks like a perfect circle, we know it's not a perfect circle. I'm just kidding, of course, not about that. And you can see, and then as I continue going along the angles, you can see here, it's shorter again, right? So, and we know it'll be this height, right? If we assume I transferred that correctly. And then here, it'll be this height. You can see what I'm doing is I'm transferring that y value over here. I mean, so here you can tell that the angles are not perfectly like, you know, like for example, this height should actually be the same as that height if the unit circle was drawn properly. But what I think you can see here is you can see that the shape, it's taking shape here. See, and then here, it's again going to be 0 at pi, right? And then it's going to start going down underneath. So at 7 pi over 6, it's right here, right? At 5 pi over 4, it's here, right? At 4 pi over 3, it's a little bit lower, here. At 3 pi over 2, it's lower still, at -1. See, here I can kind of gauge it better. 5 pi over 3 will be about that height. Then it'll be about that height. Then it'll be here. Then finally here at 2 pi, it's again 0, okay? And what you can see is that I've transferred the y values over. And if you connect these, oh my God. And if you connect this, you get that classic sine curve shape. And now, so the purpose behind what I wanted to show you here is how I wanted you guys to see first and foremost how, for example, the heights, these vertical distances for the sine, like let's say this one here at 2 pi over 3, corresponds exactly, let's go to 2 pi over 3 here, to the height of the x-axis to the sine curve itself. So you can imagine that stick is actually the same length as this stick. Now, of course, on the board it's not perfect, but you get the idea. And what I want you to see is that's true for every part of here. Like for example, this height at 7 pi over, at the angle 7 pi over 6, right? That stick height is the same as the distance below as this stick, okay? And so so you can see that as I go around the unit circle, right, the sine values gently increase and decrease. And so it makes sense that they're gonna develop a smooth shape like this, okay? I wanted you to see that. Now, of course, if you have a lot of if you're very good at drawing and if you have the drawing equipment and stuff, you could actually do this a lot neater on your paper if you wanted to, okay? But I wanted you to see this at least once. And of course, I know that if you have computer animation abilities, you can make an animation of this that will capture it even better, right? We also saw that the sine existed between the values of -1 and 1, right? Why? Because of course that's the maximum extent vertically of the unit circle being a circle of radius 1, and at the same time the maximum or let's say the minimum that it achieves is -1. For the same reason, the distance downward is 1 from the origin. Okay. Now I want to talk about something that's very important. And while I have this drawing up, and as you saw me draw it, we remember that one of the things about looking at the unit circle is that we can imagine, what if I wanted to look at angles bigger than 2 pi? What would happen? Well, what would happen is that those angles would begin to wrap around the unit circle, right? So, right, so like let's say, so if I go from 0 to pi, right, then 2 pi, then I can start increasing, right? So let's say I think of 2 pi in terms of pi over 6. That would be 12 pi over 6. So if I land here, if I've already gone the whole circle, that's 12 pi over 6, let's say. One more pi over 6, that's 13 pi over 6. But the sine value will be the same as the sine of pi over 6, right? The sine of 13 pi over 6 and the sine of pi over 6 will have the same sine value. And by the same token, if I continue going around like that, you can see that if I continue this drawing process this way, the curve will draw out the same shape again, right? Because, see, once you have gone around the circle once, then when you're going around the second time, all those same landmarks will be revisited. Okay, so that leads us to one of our observations, that the sine is periodic with period 2 pi. Okay, and basically the word periodic here, we're going to give it a more formal definition later, but it's that property of the curve repeating itself. And here we've drawn one full period of the sine curve. Okay, and now and before we leave this, I want to notate some of the important points we're going to use when we're graphing the sine curve. Okay, like I wanted to draw this for you like this with all these landmarks, so you could have so you could be convinced that it should have this delicate shape, this delicate curve associated with it. Okay, so you could see where that came from, and so you could get a kind of idea of how the sine curve, why the sine curve has this shape, and how the sine curve is supposed to look, and so on. But when we're going to graph it, the landmarks that I want you to notate are the following. Okay, so x, and again, you could think of this as like the parent function. Okay, x, sine of x, where x is the angle. So we need 0, pi over 2, pi, 3 pi over 2, and 2 pi. And of course, you can see here at 0, the sine is 0. At pi over 2, the sine is 1. At pi, the sine is 0 again. At 3 pi over 2, the sine is -1. Okay? And at 2 pi, the sine is 0 again. And of course, we know that when it continues onward like that, it will repeat the pattern. And so, yeah. But so these are the points we're going to use when we're going to graph a lot of the examples that we do later on. And so, wait, do I want to tell you one more thing? I think that was everything I wanted to show you guys about this graph. But so this is everything I wanted to show you in the beginning part of this. I wanted to show you like how to draw the sine curve like this in full detail, so you guys could be convinced that it should have this kind of delicate shape, as I mentioned. I wanted to show you these important landmarks that we're going to use. I wanted to tell you, using our construction here, why we should believe well, not why we should believe, but like you can tell, like from the argument I made, that this pattern will continue, right? If we were to continue drawing the sine curve this way, because of the fact that we would begin wrapping around the circle, the shape would be duplicated. We said that this was one period of the sine curve, and we noted informally that 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 sine was periodic, which we're going to talk about in a little bit more formally, and that means basically that it will repeat itself. And we said that it had period 2 pi, and that means that after that this, so you can see this length from 0 to 2 pi, that's 2 pi, and so that's how long it takes for the whole sine curve to be drawn, okay? And in other words, that's the period. And in other words, the period is the repeating part. How much of it is the repeating part, okay? And the final thing I want to say before we go is we noted that the maximum extent of the sine function was 1 and the minimum was -1. And so we're going to see that this distance that the graph goes from the midpoint of the graph to the extremity, whether like this or like this, that's something that's called the amplitude, okay? Or you can also think of it as half the distance from the top to the bottom. And we're going to be calculating that for some of our examples as well, okay? But in any case, I hope you've enjoyed this construction, and I look forward to seeing you again soon. Thank you so much.